Okay, speaking next, we have Edouard Viot. Edouard is a CTO and co-founder of Symbiotic, specializing in source code security. His journey spans roles from developers to security engineers to VP, with a background in both technical engineering and leadership from Stanford's project management program. Edouard is uniquely positioned to drive information in cybersecurity. Today, his talk will focus on how LLMs are solving Terraform vulnerabilities and how they compare. Let's deep dive into it. Let's hear it out from Edouard.
Thank you so much. Thank you.
Thank you.
Hi everyone. So yeah, today we will speak about LLM performance to remediate some vulnerabilities inside the source code of the developer. Sorry for my voice. The fog of San Francisco killed me yesterday. So yeah, I'm Edouard Viot, CTO and co-founder of Symbiotic Security. We focus on solving the problem real-time of the developer into their codes. We automate the remediation with some AI, and we give some trainings for the developer in the flow of their code. So I've always been in cybersecurity, mostly in engineering or product roles. So developers, security engineering, and so on. So we focus on, we choose to focus on infrastructure as code security. So, for example, Terraform file, in order to begin to build an auto AI remediating agent. Why? Because the infrastructure as code is mostly some configuration. So it's much more easy to, it's much more structured than classical languages and so on. But of course, we are working on all the other classical languages right now. You have some edge cases with Terraform code. For example, when you are leveraging some modules, Terraform modules, you may have your ways that you instantiate a module could imply a vulnerability. So you have to check multi-part vulnerabilities, things like this. But the tricky cases are really okay. And why did we focus on remediation and not detection with AI, for example, or things like this? Because LLM are really good to generate some languages. So remediation is all about writing some code in order to patch a vulnerability into the code. So LLM is a perfect field to play with. And in infrastructure as code, to be honest, detection is near to be a commodity. The customers are okay with the detection today, but what is really difficult is to remediate hundreds or thousands of vulnerabilities at scale. So our main objective when we work on this AI project for remediating was to find the best model in order to remediate vulnerabilities, to leverage strong data. So not leveraging public data, but the data of our customers that we worked, and to build the best inference. So an inference is our way to do a prompt, for example. So this is a little bit complicated, but it is our test pipeline. I will try to sorry for my voice. But so we made a test pipeline. We generated a lot of vulnerable code, more than 300 types of vulnerable code. On top of it, we generate some detection rules. And then we leverage the LLM, asking, okay, here is a vulnerability, here is a good example, a secure example, please correct this vulnerability. We ask it to the LLM, and then we test with our detection engine if the vulnerability has been well remediated or not. And we compared a lot of models, we compare a lot of different prompts in order to have the best results. This is not the prompt that we are using, but it's just an example. We leverage on a really simple technique, which is templatized prompt. So the idea is to have some parts that we will inject. So we inject the vulnerable code each time, but also some description, some recommendation to the AI, but also good example of code, so that the AI could inspire from our data. So meaning that we are not leveraging on classical AI model, but we are augmenting them directly into the prompt. So, like you can see, Claude AI 3.7 Sonnet is really acting the best in our tests. Nearly 95% of good remediation of vulnerabilities inside the code. It's not out of the box result. If you just do a dummy prompt with Claude AI, maybe you will reach 80% of good remediation. But if you, in the prompt, if you insert quality data on top of it, you can reach this type of numbers. Then you can see that, yeah, quite all of them are doing good. If you have the good prompt, smaller model could have less results. So the main learnings that we had, without injecting our own example, they were a clear plateau into the AI model, meaning that, in fact, all the AI model today, they are learning from public data, like GitHub public repositories, for example, and so they are all learning from the same sources. So if you put your own quality data on top of the model, you reach from 70-80% to 95% of a good remediation. The second one is you have really to verify the output. 1/3 of the time you ask to only answer with some codes. It will give you one sentence in English. It will have a small syntax problems that you need to correct after the AI made its job. I don't know if you are familiar with the temperature, but temperature, when you are using a model, if it's close to 0, you say to the model, okay, don't be so much creative. And then the model will be really idempotent. You execute it several times, you will have the same types of result. If you give an high temperature, one temperature, for example, it will be more creative. But so it's true in English, for example. If you give an high temperature, you execute several times, it will speak differently. But with the source code remediation use case, to be honest, the temperature is not so much noticeable. The last thing is the family of vulnerabilities. So we don't see a huge difference if the vulnerability is from Amazon, Microsoft or Google. It's quite the same result each time. It's not really noticeable. But if we speak about technologies, for example, OpenStack, the model are not so good in order to remediate to an OpenStack vulnerabilities, for example. So for us, the next step is to continue to build high quality data to augment the capabilities of the AI models, but also to leverage an agentic approach. So agentic approach means maybe you will have one agent where you will ask to remediate the code, and then after you will have one agent saying, okay, if there are some syntax error in the generated code, please correct them. And then you will lower the number of errors that the AI could do. Another way to do an agentic approach is to leverage some specialized prompts. Let's say, for example, there is one family of vulnerability, SQL injection, for example. I will do a specialized prompt just for this type of vulnerabilities, so that I don't anymore do 95% of remediation, but 95, 99 or 100, for example. That's it for this lightning talk. Sorry for my voice again, and thank you. And if you have any question, please let me know. Thank you.